Daily lead code problem. Minimum number of arrows to burst the balloon. This is basically, you have been given a array representing balloon. So this 10 comma 16 represents starting and ending time of the balloon. Not ending time, you can say starting index or ending index or positions of the balloon. And these balloons are like lying in this manner. So you can see there are some spherical balloons on a flat wall represent xy plane. Point x is x start comma x end, basically starting of balloon, ending of a balloon, whose horizontal diameter stretches between the start and end. And arrows are being shot up directly vertically up, so basically you are shooting the arrow. So if you shot arrow in this range like 10 to 16 wala, then your that would be burst, your balloon would be burst, right? Now, we want x start and x end. There is no limit the number of arrows can be shot. Okay. Basically, we want to return the minimum number of arrows that we need to shot the balloons, right? Okay, so how we are gonna do this? Basically, we are gonna use the property that some balloons are overlapping. So, if one balloon is like this, okay, it's kind of an horizontal thing I'm drawing over here. And let's say this is the first, which of this is what? Like, let's say this is the starting time of S1. And this is the starting point of S2 balloon. And this is ending point of S1 balloon. Even this is ending point of S2 balloon. Okay? So you will say ki, this balloons are lying in this. First balloon is this, second balloon is this. Both the balloons are overlapping, so I can shot a arrow in this range and such that it will burst both the balloons. Is it possible? Right, it is possible. If I shoot the balloon in this range, this is in the range of E1 also and SE2 also, right? Sorry, yeah, balloon 1 and balloon 2, and it will burst both the balloons. So that's what you need to tell. Okay? Return the minimum number of arrows. Yeah, so how we are gonna do this now? The point comes how we are gonna do this. First of all, you should sort this array. Usse bhi pehle, the basic logic for this problem would be, uh merge some overlapping sub intervals. Okay? Overlapping intervals ko we try to merge. This is a pretty standard kind of a problem, so let's see how we are going to do this. So this is 1 comma 6, and then you have been given 2 comma 8. I'm just sorting this in a correct order, right? And what is basically how I'm sorting this? I'm sorting it on the ending time. Maybe you can sort it on the starting time also. That doesn't make much difference. So ending point is 12, next ending point is 10 comma 16. This is the order of the sorted order in the sorted by ending point 6, 8, 12, 16. Right now what we are gonna do, we are gonna say ki, which of these are overlapping. 1 to 6, 2 to 8, that's overlapping, right? Because 2 lies between this. So 2 lies between this. Before ending this part, 2 will get start. So how does balloon looks like? This looks like something like this, right? This is 1, and let's say this is my 6, and this is my 2, and 8 is somewhere over here after the 6, right? This is how balloon looks like. Now this is 2. Okay, this 7 is basically between the 6 and 8, right? First balloon has ended, second will now, third will start, right? And this end over here. Now 10 is starting at this point. Let's say 10, this is 12, right? I'll mark it basically what it is. Currently it's just looking so much. Yeah, so 1, this is 6, this is 7, this is 8, this is what is this is 12. No, 1, then 2 will start at this point, 6 will end at this point, 8 will end at this point, and so this is the first balloon, 1 comma 2, second balloon 2 comma 8, and then you have 7. Okay, I think I'm most to this, so this is 7, right? That's why it's an opening balloon. So this is 7, and this is 8. So first balloon is going from 1 to 6, right? That's about it. Second balloon is going from 2 to 8. That's about it. The 7 is basically the starting of the next balloon, which will end at a point of 12. This one will end on the point of 12. So but before that there is something starting at 10, and then you have 12. So now you can see, what is the overlapping ranges. Overlapping ranges, as you can clearly see, this is a particular overlapping range. 2 to 6 part is coming in both this 1 to 6 wala and 2 to 8 wala, right? So this is the basically overlapping, one kind of an overlapping. And then you have 7 to 8. This is basically not overlapping with anything, because let's say 1 to 6 wala this, 6 to 2 to 8 wala this. Now both this have overlapping part is ended. Now this part is basically of 7, and this part is basically of 2 to 8, yeah, 2 to 8 and 7 to 10. Maybe you can, if you let's say you shot first arrow in this range, right? Let's say if you draw first arrow in this is gonna be helpful because it will burst both the balloons, right? um, Something like this. And let's say if you burst another balloon like this using this arrow, this is not gonna burst anything other than just 7 comma 12. Why? Because 2 comma 8 and 1 comma 6 is already burst by using this balloon. So why not find this intersection and burst it over there? So 10 comma 12 is that intersection which is occurring in both these. So I just want these two arrows to be shot. Now basically, as I said, you will just have to don't have to do this, you have to just merge the intervals. So for example, uske liye what is the logic? You will to see that what is the ending point. 1 comma 6 is the ending point. So take every balloon which starting point is less than 6. Okay, 1 comma 6, and then you have something like let me put it like this, yeah, 1 comma 6, and then you have something like 2 comma 8. You can't include 7 in this, like as I said that starting point should be less than 6. Okay, no, 7 is not less than 6. Now 7 will go in another other bracket, you can say. And yeah, let's draw the bracket and 7 comma 12. Now you can include every such balloon which is starting before 12. 10 is before 12, so 10 can be included in this. These are the two basically, your overlapping parts, and you will use two arrows to burst each of them. So how I'm gonna do this, I'm just gonna do this logic while your starting point is lesser than your previous ending point which you are saying. So let's say for int I equal to 0. Very straightforward question, just you have to merge the overlapping interval, right? I hope you got the idea. Idea was basically, again, if I have to repeat, you just see what are the balloons and what is the overlapping part and how you can, burst those balloons using overlapping part. So for that overlapping, you just need to see, uh, you know, it looks like this. A1, if this balloon is B1, B1 is overlapping with B2, right? B1 is overlapping with B2. There is some connection between B1 and B2. B2 is also overlapping with B3. 2 and 8 and 7 comma 12, there is a connection. B3 is overlapping with B4, we know. But the how we can burst these balloon, if you shot an arrow on this part, then it will burst both B1 and B2. Okay, if you shot an arrow on this part, it doesn't make sense because B1 and B2 are already burst. But this what this arrow will do, this arrow can burst B2 and B3 together. But even if you burst B2 and B3, there is no connection between B1 and B4, so you have to use separate arrows for them. So why not do it like this? And whenever this kind of case appears, so you must burst the adjacent element like B1 B2, and then not B2 B3 but B3 B4, something like that. So that's what it is. That's what we are doing. Let's try to implement this up. If your starting point, first of all, let's say what is my limit. P is my limit, P of I comma 1, currently the ending point of this point. And what all I can include in my current this, while your next point, which is P of I plus 1 comma starting point is lesser than this ending point, or even if it is equal to, it can be just come into this. You have to just say I plus plus, right? And that's about it. You can say the z plus plus, how many times it is entering into this loop. And int z equal to 0. Z is basically the number of balloons, arrows that you need to shot. N is equal to p dot size. P is my point array. Let me just change the name to p. And that's about it. Why this z plus plus is over here, not over here? This is basically, you are seeing that how many elements I can, how many balloons I can just burst by using this arrow, kind of this arrow E. And then you will go up to that point. And but you don't need to do z plus plus for all of them. You just need to do z plus plus only once for one particular balloon like 1 comma 6, and 2 comma 8 will burst by itself. But when you come on 7 comma 12, you'll see that this condition is not holding true, so you have to just break out of this loop and again go for 7 comma 12 and then z plus plus for 7 comma 12. In this way your z will be something like 2 in this case, and it will be correct in all other cases. Let's see. 10 minutes. Okay, why? Yeah, you just need to check for this constraint. I plus 1 should be less than n. And you cannot go out of the bound. That's about it. Pretty straightforward question. Merge overlapping intervals. What is the issue? You just not sorted the array. You have to sort this first. That's what I told in the beginning. But yeah. I want to see, does the normal sorting work? I think it should work. Let's see. If it doesn't work, you can sort around the ending index. That will surely work. Yeah, it's not working. It's not a string. And vector, one is my ending index, as you know, and that's about it. Okay. You can also, just see what this test case and how it's not gonna work when you just normal sort it. You have to sort it around the ending index, because there can be cases like, when this starting point is this starting point is less, but ending point is very far away, and between this you have, just so many balloons like this. Starting point is this, then ending point is this, and this was just basically for starting. you know its ending point is so far that you will see that all are just coming into one, but it's not possible. Let's say this is the basic case what I'm saying now. Ki balloon 1 starts from this point, let's say S1 starts from this point, and it's so far like E1. So you will say that every balloon whose starting point is less than E1 will gonna burst by using just one arrow. It's not possible when this balloon is, S1 is basically this, and S2 is E2 is basically S2 and E2. That's what I'm saying. Do you get it, like what I'm drawing over here? Like, if this balloon, is there, and this is one balloon and this is one balloon, this cannot be just burst by using one arrow. It needs at least two arrow, one for this, and it will also burst this part, and now this is gone. Even S1 is gone, and S2 E2 is gone, because you just burst this and you need second arrow for this one, right? So that's about it. And let's try to sum this up. Okay, as you can see, pretty good efficiency. Let's move to yesterday's problem. Okay, so this was yesterday's lead code problem. Basically, I'm covering this today. So this is basically minimum rounds to complete all tasks. You have been given a task array, which contains some number. Basically, task I represent the difficulty of this task in each round. You can complete either two or three tasks of same difficulty level. So you can complete either two or you can complete either three. There is no possible way to complete just one task. If this is basically this, the array you can see, if you just give it a test case having just one element, and this element can be anything. It can be one, or it can be 1 lakh one, or whatever it can be. But this is not possible. Why it's not possible? You cannot, you need at least two or three tasks of same difficulty. Yeah, as you can see, -1 is the answer which we return when it's not possible to complete all the tasks. Okay, so you can either complete two tasks or you can either complete three tasks. Okay, that's about it. Like, yeah, and every number that you can form in combination of two and three will always be also be possible. So I think the every number, so the any number which remains is just one, and two is or definitely possible. Three is also possible. Yeah, four is possible. No, four is also not possible, because it's you can. Oh no, four is also possible. Four is a set of 2 comma 2. Hmm. Hmm. Four is also possible if you have two fours. Sorry, four twos. That would be possible, I think. Let me see. There was a wrong summation for that, I think. Uh, yeah, I think that should be okay. Hmm. As you can see, 2 comma 2 comma 2 and 5 comma 5. You need expected 2. Yeah, how many that you want, right? Yeah, so 4 is, if you have same number 4 times, that is also accepted. Same number 2 times is obviously, three numbers obviously, and 5 times is obviously, because 3 plus 2 you can do, and any other number you can just go. But what you need to tell, you want to tell the minimum number of rounds required to complete the task. So at, for example, you have uh, occurrence of 2 4 times, and occurrence of 3, let's say, 7 times. How many, this is all arranged in any format. In this, I don't know whether this is okay, this is not the case, but let's see for this array, let's just focus on this array, forget about this for time. So this array, you can see the frequency of 2. What is frequency of 2? I think it's 3, right? 2 2 2. I can see frequency of 2 is 3. 3 key frequency is, I think, 2, and then you have two tasks of difficulty 3. 3 of difficulty equal 2, and 3 plus 2 is 5 frequency, basically 4 frequency is 5. Now what you can do, you can complete 2 or 3 tasks of same difficulty, like two difficulty, like same difficulty, like there are 3 tasks having same difficulty as 2, so you can complete this in just one operation. There are 2 tasks having same difficulty as x number, which is 3 in this case, so you can complete this in just one task. And this is 5, basically you cannot complete in one task, you can complete either 2 or 3, and remaining one, it would be, if you take 2 for first time, remaining one would be 3, you can take it in the next time. So basically, how many operation? One operation required for this, one operation required for this, and two operation required for this. The total will be equal to 4, right? That's all what you need to do. You just need to see the frequency of every element, like, but because you cannot, you can only just complete the task of the same difficulty at a particular time, so you will cover all the two at, not all two, but basically two twos or three twos once. As you can see here, I'm covering two twos at once. No, not only two, basically three. I have two three times, so I'm covering it in once. Okay, that's what it is. You just need to create a map and then frequency, store its frequency, and z equal to 0 is basically the answer which you are gonna get. And for auto I in m, this represent, I'm going for every number like 2 3, and 3 is ring 2 times. For every element in map, I just need to see what is its frequency divided by 3, because in the worst case, what happens then, the frequency is something like this 7 I just told about. So 7, I can use, how many operations do I need to cover the 7. So first I can cover 3 in just one time, and then 3 in just another time. Now you are left with 1. You cannot do 1, right? So let's say you do 2 at this time and you do 2 at this time. So now in this way you can cover it in the 3 operation, which is, 7 divided by 3 is 2, and that's why plus 1 for that. So 7 divided by 3 is 2 is the operation which you lead at least, because in 2 operation you can cover 6. That is still less than 7, right? Now there is a thing that, if x is equal to 0, okay, and this is I modulus 3 is equal to 1, or you could have just said that I modulus 3 is not equal to 1. Basically you can just say that x is equal to 1. Your not x equal to 1, I dot second is equal to 1. When you have just, what I'm doing, when you have just only one element, return -1. You cannot pair it with anything else. And else if you can just see if this modulus 3 is 2, like remainder is 2, or even remainder is 1, like in all other cases, okay. Like you can just say if not of, else if, uh, remainder can be anything else other than 1. No, it can be 1 also. So 1 2 0 1 2, these are the all possible remainders. So I don't think we have to do else if, you can just write else, because even the remainder is 1, even the remainder is 2. You can just do x plus plus for this one operation for this, because when the any other number which has, remainder 1, basically 7 or 4, this can be covered by using some twos, right? And combination of twos and 3, so that's why x plus plus for that, and z plus equal to x. Yeah, this is the total number which you want, right? Let's try to give it a run. So question was very simple. You just need to see how many, rounds you need for each of the task. So for, and then sum them up. So basically Z is using for summing them up. But for calculating how many rounds that you need for a particular task of same difficulty, you can store it in map and see what is its frequency divided by 3. If it's just 1, then you have to return minus minus. If it is something like this, else Z plus plus. You have to write if, else if, what, x modulus 3 exists, it can be 1 2 or anything. Yeah. For 3 you don't want this, right? Now let's try to sum this up. Okay, 3 comma 3, basically you will say that 3 has a frequency of 2. So now, this is not true, this is true, x plus plus. I dot second cannot be -1, right? Output expected. Oh, I did x kya? Oh no. I dot second, sorry. Modulus 3 should exist, right? Basically, this is your frequency. Its modulus 3 should exist, something like 1 or 2. Then we have to do x plus plus. Otherwise, if it's completely filling the bar, so we can just, take the multiple of 3. That's about it. Okay, guys.